Hello, hope you're doing great. This is Maria Panni Rajan, your friendly software engineer. And in this video, we're going to talk about how data is stored by a computer. When you think about it, data is meaningful only for us human beings. For a machine, it doesn't make any difference, right? And computer being yet another machine, just like a fan or a AC or a mixie or a fridge, the only two states it understands is either being on or off. So how does a computer, which is just a machine, and a machine as we know can only be in either on or off state, is storing all this complex piece of data that we are giving to it? How is the computer able to store numbers and do calculations on them and return back the answers? How is a word processing application like MS Word is able to understand the text that we are typing into it, store it, and then when we need it, open the document and show that text information that we typed into it? How is all these things happening? This understanding of how machines are storing human data and processing them and giving it back to us is very crucial for us as software engineers. So that's what we're going to talk in depth about in this particular video. Now, we have established the fact that as a machine, and computer being a machine, can be in two states, which is on and off. What we have done as human beings is cleverly put together a bunch of switches together, all right? And we know that every switch could be in either on or off position, right? So basically what we have done is, inside of the computer, to store data, we have these things called the hard disk, which we would be familiar of, right? Like in even our mobile phone for that matter has a memory card, right? And similarly a laptop or your desktop PC will also have a hard disk, and the hard disk stores persistent data, as in, all the data that you want to be stored even after you shut down your computer, you store it inside this persistent data storage called the hard disk. And there's another type of disk called the RAM stick, which stores non-persistent data, right? So like data that you only want to store temporarily. And these physical devices such as the hard disk and your memory RAM, it contain many small tiny switches, all right? And by means of either turning on or turning off these respective switches, we can set different states, right? We can set the hard disk or the memory RAM stick to be in different states. Okay, that is how we as human beings have engineered, right, these machines to store and retrieve data. To illustrate this further, consider that this is your hard disk. Okay, so in your hard disk you would have a bunch of these tiny switches. Okay, and we know that each of these switches could either be in the on state or in the off state. So for the on state we represent it with the number 1, and for the off state we represent it with the number 0. Now each of these tiny switches inside of the computer is what we call as a bit. Bit is the smallest piece of data that can be stored inside of a computer, which is either on or off, right? Because it's just a machine, right? So each of these things, this is a bit, this is a bit, this is a bit, this is a bit. Each of these tiny switches are called as a bit. Now, even though bit is the smallest piece of data that could be stored inside of a computer, it is not the smallest piece of data that could be stored or retrieved by human beings. All right. So the computer, yes, it stores data by means of using these bits. But for us to store and access data, we use a slightly bigger unit of switches, okay, which is basically 8 switches together. Okay, so here you have switch number 1, 2, 3, 4, 5, 6, 7, 8. So 8 switches, 8 bits together is called as a byte, B-Y-T-E. Okay, so 8 bits make up 1 byte, and 1 byte, all right, is the smallest piece of data that is accessible by humans. Okay, we can't directly go and access every bit of data. Okay, so that's something that we need to keep in mind. Okay, so what does this all mean? How is the computer storing and retrieving for us complex pieces of data such as music, audio, video, text, numbers, colors, and so on, how is it doing it? By just making use of these bits and bytes. To understand this, we need to talk about binary. Now, in a high school, we would have learnt about binaries and converting binary numbers to decimal numbers and from decimal numbers back to binary numbers. At the time, honestly, I didn't have a clue as to why even we are bothering learning all these weird number systems such as binary and decimal, hexadecimal, and so on. But especially this binary number system is very important. That's basically the fundamental of computer science, because um, the computers work in binary, right? As we already talked about, each of these bits, it could either be 1 or it could be 0. So that's it. So since each of these bits, which are basically switches, could either be in a 0 state or in a 1 state, which is essentially binary, what we are doing is we are making use of these switches to store binary data. Okay, so that's essentially what we're doing. So before we see how we can represent data by means of using these individual bits which make up a byte, let's just have a quick refresher on the decimal number system that we are naturally accustomed to using, and also let's talk about the binary number system. So in the decimal number system, deci meaning 10, so every place is basically a multiplication of tens, right? So basically you have ones place, and then you have tens, hundreds, thousands, and 10,000. How are we arriving at these tens and hundreds and thousands places? The way we are arriving is by means of using this formula, which is basically 10 to the power n, right? So in order to understand the zeroth place, we just say 10 to the power of 0, which is 1. And then the first place, we just say 10 to the power of 1, which is 10. And the second place, 10 to the power of 2, which is 100, and so on, right? So so because we have these like places in place, no pun intended, we can easily say, if you want to represent the number 10, all we need to do is go over here and put 1, and then like put 0. We don't need the zeroth place, right? And if you want to represent the 110, you just put 1 over here. So this is 110, right? And if you want to represent 115, all we need to do is, since we are already having 110, we just need like some 5 digits over here, so it's 115, and so on. So that's how we represent numbers using the decimal number system, correct? So now let's just have a quick look on the binary number system. So the binary number system is also like very similar to this decimal, but the key difference here is, like, instead of using 10 to the power of n, we use 2 to the power of n, because this is a binary. Binary means 2 digits, right? 0 and 1. Now 2 to the power of n. So using this, we can quickly tabulate the places that are available for us. So we can just say, like, so the 0th position would be 2 to the power of 0, which is basically 1, and then the first position would be 2 to the power of 1, which is 2, and the second position 2 to the power of 2, 4, and 0, 1, 2, 3. The third position 2 to the power of 3, which is basically 2 to the 4, 4 to the 8, and and then here it will be 16 and 32, and so on, right? So this is how the places are set in the binary number system: ones, twos, fours, eights, 16s, and so on. Just as how we had ones, tens, hundreds, thousands, and so on. So here, like, in order to represent the number 1, all we need to do is put a 1 over here, right? And if we want to represent the number 2, all we need to do is just put 1 over here, and turn this off, like put 0 here. And if you want to represent number 4, 1 here, 0, and 0. And if you want to represent number 6, all we need to do is turn this place also on. Okay, so now you have 4 and then 2, which added together makes up 6, right? And then if you want to represent the number 7, like, you just need to turn this switch also on, this place also on, right? So this also, if it's turned on, this becomes 4 plus 2 6, 6 plus 1 is 7, and so on. So now the thing is, the very interesting thing now, what is happening here is, just by means of using zeros and ones, right? So like, if you want to represent the number 5, if you just put 0 over here, like, 101 is the number 5, right? So we can represent our human understandable decimal numbers by means of just using 2 digits, which is 0 and 1 in the binary number system, right? So this is so fascinating, and like, using this binary number system, which works with just 2 states, which is 0 and 1, which is very much similar to what we have got here, which is basically switches, which also could be existing either in 0 or in 1 state, we can represent whatever number we want if we just have enough bits and bytes, right? So with a byte, right, which basically has got 8 bits, one byte is made up of 8 bits. So with just a single byte of memory, and we know that a single byte contains 8 bits, right? So with just a single byte, one byte of memory, we can store 2 to the power of 8 states. Okay, so which is basically 256, right? 2 to the power of 8 is 256. So that means we can store 256 different states, because like, just imagine. So this is basically just like what we have over here, right? So let's say we have 8 like places. So basically 1 2 3 4 5 6 7 8, so 8 places, right? So this could be like treated as one byte, which is made of these 8 bits. These are all the different 8 switches. So if you turn on all the switches, okay, like theoretically, if you turn on all the switches, what that means is, if you just add 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, so it's basically 255. And if you consider the zeroth state, so if everything is 0, that's also considered to be a state, right? So with that, you get 256 different states, 0, and like all the different combinations, and you go to maximum of 256. So basically 2 to the power 8, which is equal to like 2 to the power of 8, which is basically 256. If you just turn on all the switches, the maximum value you get is 255. But there is another state, which is basically if you turn everything off, if you just put everything to 0, that's also a state, right? That's also a representation. You're representing the number 0. So totally you have 256 different numbers which can be stored in just one byte of memory, right? So this is just one byte, and we know that today's machines have like thousands and thousands, as a matter of fact, lakhs and lakhs of bytes of memory at our disposal, right? Like, so just imagine the possibilities, and that's the reason we have all these complex pieces of data stored in the machines. So just to give you a quick glimpse, here is like we are using Google to find out what is 1 KB of data, right? Like 1 KB, 1 kilobyte, which is considered to be a very small piece of data. Usually text files are like in kbs, right? So 1 KB is equal to 1000 bytes, right? So 1000 byte is basically if you just multiply 256 into 1000, that's what it is. 256,000 states could be stored in just 1 KB of memory, right? And in 1 MB, 1 megabyte, there is actually like 10 lakh bytes make up 1 MB. And if you want to see how many bytes are there in 1 GB, like yeah, that's a lot of, that's a big number. Okay, but anyway, you get the point, right? So like maybe you can convert it to megabyte or something and see. So yeah, 1000 MB megabyte make up 1 gigabyte. But you get the point, right? So basically, like this is how the memory system is built in our computers. So it's not magic, it's just clever engineering, right? So machines cannot and will not be able to process human data in the way we as humans do. But what we have done as human beings is set up a bunch of switches, because machines understand switches, right? So we have just set up a bunch of switches, and using the binary number system, we are representing our decimal numbers in binary by means of using these switches. Okay, so this was a quick introduction into how like data is being stored by computers. I hope this video was useful, and I will see you again in the next video. Cheers.